many sixes. So watch how this works. It's actually very simple. I just take z equals, I go 0.73 minus 0.75, and I divide that by the square root of 0.75, just like we did before, times 0.25 divided by 3011. And let's watch what happens. So let's see, what do? I'm going to take negative 0.02. So negative 0.02, and I'm going to divide it by the square root of 0.75 times 0.25, and I'm going to divide that in there by 3011. I really do need to get that thing, don't I? And this is, watch this, negative 2.53. Which means that for this test, right here, this point estimate, where did it end up on the curve? Well, here's negative 1.96. This is the line of demarcation. If you cross this line, something is fishy. And sure enough, I crossed that line. This right here is my z-score, which is negative 2.53. Alarm bells are going off. Well, we knew they were going to go off because when we did the confidence interval, we were screwed. Guess what? We reject the null. We will either reject or accept the null. Think of it as, again, it's a binary situation. We either accept this or don't. And in this case, we throw it out. And again, we wouldn't write up the same write-up. In class, we'll go over how to write these write-ups up because this write-up has to do with the confidence interval, but it's very similar. There is evidence that the population for proportion for adult internet users isn't 0.75. Now, I'm going to do it one more time, and we've actually done the heavy lifting for the proportion. Watch how this works. I got to remember that z-score. The last way to do this is, I'll go ahead and change it up here, is something called a p-value. And I want you to notice all three of these are going to give you the same thing, or are going to give you the same conclusion as far as accepting or rejecting the null. But the thing that's most important is you basically get to pick it. You get to pick your favorite. Now, I'm going to force you to do certain hypothesis testing with certain ways. With either the critical value, remember this right here is called the critical value method. This is the confidence interval around the proportion. And then what we're about to do is called the p-value. But again, the p-value is already, if you've already done the critical value, then the heavy lifting is already done. Your computer does it with p-values. Now, the p-value is actually real simple. All you do is find the z-test statistic, right? Which we know was 0.73 minus 0.75 divided by the square root of 0.75 times 0.25 divided by 3011. And we ended up, what was it? I forget what it was. 2.53? Was that what it was? I'm getting old. Negative 2.53. Negative 2.53. Now, what does that mean? It means, remember, sample proportions, unbiased estimator, not only that, but they distribute themselves on a normal curve. Wow, that was a train wreck. However, in total absence of critical values, we don't even have to worry about them. With p-value, what we're going to do is we're going to find the probability that we get a value at least as big. Okay, so my z-score or my z-test statistic was negative 2.53. All right, now that tells me that my p-value is the following. I'm going to go over to my curve. All right, let's get over to my curve. We're on the standard normal. And we're going to figure out, let's see, what do we say? Negative 2.53, so negative 2.5 and negative 2.53, 0.0057. Remember, it gives us all the values to the left. So 0.0057 gives me let me double check. I'm getting a little punchy. All right, so back here, that implies that the probability of getting a value at least as extreme, in other words, of ending up out in this crazy land, is 0.0057. That's a very small amount. But the question is it small enough? And the answer is yes. All right, here's why. Now think about this. I'm going to redraw my curve because that one's just horrific. Because it's two-tailed, that means that I'm going to have a couple of, now this is really easy to explain, especially once you've seen critical regions. What I'm going to have is I'm going to have a 0.025 on the top end, and I'm going to have a 0.025 on the bottom end. All right? Now remember, the null and the alternative, my null hypothesis was that P equal 0.75, and my alternative hypothesis was that P wasn't equal to 0.75, which means that I can miss on either side. Okay? My p-value ended up being, now that, remember, this p-value is different from, this is actually a probability value. It's the probability that I get a value at least as big. It ended up being 0.0057. All right, because when I did my test statistic, I need to change. I know that I'm repeating myself, but trust me, it's a good thing. My z was negative 2.53. All right. Now, remember that 0.025 came from alpha divided by 2, because alpha divided by 2 was 0.025 because alpha equaled 0.05. Now, this happened because of this inequality right here, because it's not equal to. If this p-value is less 0.0057, because it's less than 0.025, which would be defined by this critical region right here, this critical value right here, which we knew was negative 1.96. But remember, we're ditching the whole critical value thing, although we'll keep revisiting it over and over and over. Since 0.0057 is less than 0.025, we're going to reject the null. In other words, the probability, the likelihood that I get a value at least that extreme, that I get a 0.73, which to us may seem, well, that's not very far off. Yeah, but taken in context, think about that. The number of people that were surveyed, the law of large numbers tells me I better start heading for 0.75. The problem was I didn't get close enough to 0.75. So the probability that I get this 0.73 or a value that's at least extreme is only 0.0057 or 57 out of 10,000. Now we have agreed that the acceptable amount of probability we're allowed to have is 25 out of 1,000 or 0.025. And therefore we reject the null. There's enough evidence to reject the null because of this p-value right here. So, in summary, and we're going to do one more of these, guys. I know that you guys have hypothesis testing takes a long time. So these are going to be some pretty long modules, but don't panic. We'll get you through them all. In summary, there's 3 ways to test this kind of null and alternative hypothesis: equality, inequality. You can do a confidence interval, you can do critical values, and then you can do p-values. All right? Now, take a break. Take a deep breath, walk it off, get something to eat, hang out with your friends, do whatever. Excuse me, because what we're going to do is we're going to do that other proportion one. We're going to test that other claim with some data. And that guy, where was that? 0.75. We're going to do this one. Polygraph results are accurate more than 80% of the time when you come back. All right? Take a break.